Hello, I am Flash Isaac, and I have just one job today to make you understand resolution of vectors. Resolution of vectors. I promise to make this class as simple as possible, as detailed as possible, and as interesting as possible. Less of the talking, more of calculations until mama calls. Resolution of vectors. Physical quantities can be described based on their size alone or based on their size and direction. For example, if I ask you what is the mass of the object and you say the mass is 2 kilograms, you are correct. I may not expect anything more from you. But when it comes to force, and you tell me that a force of 2 Newton acts on an object or on a body, it may interest me to know the direction, because forces act at a direction. What direction is the force acting? This takes us to scalars and vectors. Scalar quantities are quantities that are described by size or magnitude alone, no direction. Example, mass. What is the mass? 2 kilograms. The size is okay. We don't need to know the direction of the mass. So, as other examples of scalar quantities are length, temperature, speed, time. These are scalar quantities. They have just size or magnitude, no direction. We don't care about their direction. On the other hand, we have vector quantities. These are quantities that are described by magnitude and direction. Examples are forces, force, acceleration, momentum, velocity. These are vector quantities. They have both magnitude and direction. When you are describing them, you tell us the magnitude and you tell us the direction or the angle. Now, what does it mean to resolve vectors? Resolving of vectors simply means splitting of vectors into various parts or components. If we are splitting vectors into various parts or various components, it simply means that vectors have parts and they have components. This takes us to 2 dimensions and 3 dimensions. A vector can either be 2-dimensional or 3-dimensional. 2-dimensional vectors, they have 2 components, the vertical component and the horizontal component. For 3-dimensional vectors, they have 3 components, the vertical, horizontal, and the third component referred to as the z component. Now, if you've ever gone to the cinema to watch 3D movie or you've played 3D games, you'll notice that instead of objects coming at just x and y axis, you see a third one coming to you directly. So they shoot a gun facing you, you see it coming to yourself and you get scared. That is the 3rd dimension. But our focus here will be more on 2D. And in 2 dimensions, we are focused on splitting vectors or resolving vectors into 2 components. And what are the components? They are horizontal, that one is gone, and vertical, gone, horizontal, and vertical. Now, representing it with graph, we represent the vertical component as the y-axis and the horizontal component as the s-axis. So here is the positive y-axis, here is the positive s-axis, negative y, negative s. Now, this is a right angled triangle. Here is 90 degrees. This is another 90 degrees. This is another 90 degrees. This is another 90 degrees. Take a look at something. If a force acts this way, let's say 2 Newton, or a vector acts this way, 2 Newton, we will simply say that the vertical component of the vector is 2 Newton. If a force acts straight this way, we will simply say that, let's say a force of 3 Newton, we will simply say that the horizontal component of the vector or of the force is 3 Newton. So when we mention force acting, acceleration acting, velocity, these are vector quantities. They are all referred to as vector. Resolution of forces, we are also resolving vectors because forces are vector quantities. So if I ask you in this case, what is the horizontal component? And you say 3 Newton, you are correct. And if I say, what is the vertical component? And you say 2 Newton, you are correct. And in resolution of vectors, we look for a value referred to as magnitude or the resultant vector. Since this is acting here and this is acting here, when you combine the effect of the vectors or of the forces, what single value will it give you? That is the resultant. And how do we find resultant? You simply find resultant using what we refer to as Pythagoras theorem. Because one force acting here, one acting here, the resultant squared is equals v squared plus a squared. This is obviously similar to Pythagoras theorem, which states that in a right angle triangle, the square of the hypotenuse is equals the square of the opposite plus the square of the adjacent. So that is the analogy we are using here. And the resultant is simply the square root of v squared plus h squared. For a vector like this, where you see this going here, and when you complete it, you have something like this, a right angle triangle, it is very easy for you to substitute 2 squared plus 3 squared and you'll be given the resultant. Or if you are looking for the angle, the direction, you say tan theta is equals v over h, and the theta is equals tan inverse of vertical over horizontal. This is simply the idea of vector. You are given vectors, you resolve them into the vertical component, you resolve them into the horizontal component, then you look for the magnitude or the resultant using this formula. You square the vertical component, you square the horizontal component, and you look for their square root. Then for the direction or for the angle, tan of the vertical component divided by the horizontal component. Theta is tan inverse of vertical over horizontal. Is that always the case? No. Here we are lucky because this force is acting up, this is acting down. Vertical, horizontal. It is not inclined. It is not acting at an angle. When a force is inclined, the story is different. Yes, it is different. Look at it. If I give you something like this, and something like this. So we know that this is your vertical axis, right? Normal graph. This is your horizontal component. What if a force of, say, 2 Newton or acceleration of 2 meters per second square is acting here, then at a particular angle, let's say 30 degrees. And I say resolve the vectors. We used to say the vertical component is 2 or the horizontal component is 2. In fact, let's do something like this. So let's say a force is acting here. Here is 3 Newton. Good, very good example. We used to say that the horizontal component is 3 and the vertical component is 2 Newton. Would you say that like we did here, saying horizontal is 3 and vertical is 2? No, no. You cannot call this force vertical force because it is inclined at an angle. Can you also call it horizontal force because it is bent? You cannot call it horizontal force. Take note of this. Anytime a force is inclined or vector generally, anytime vectors are inclined at angles, they have 2 components. So you cannot say they are vertical or horizontal. They are both. You resolve them into the vertical component, then you resolve them into the horizontal component. That is the whole idea of vector. And once you incline a force at an angle, then sine, cos comes to play. You either use cos to resolve or you use sine to resolve. A question comes to mind: when to use cos and when to use sine. The next thing I am about to tell you will help you in the future, in the present, and you may regret that you did not know it in the past. When you are resolving angles, vectors, forces, or anything that is inclined, and this is moving in a particular direction, you ask yourself, this is the horizontal component, this is the vertical component. If I am resolving this to the horizontal component, it means I am pushing this way. If I am resolving this to the vertical component, it means I am pushing it this way. If I am pushing this 2 Newton force down, what is happening to the angle? I am closing the angle, that is cos. If I am pushing this force this way, what is happening? I am opening up the angle. Look at it, I'm drawing the angle. If you are opening up the angle, this is sine. So anytime you see forces inclined, anytime you are closing the force, it is cos. When you are opening up the force, it is sine. So maybe you have not always have the mind that if you are resolving to the horizontal, it is cos, and to the vertical, it is sine. No. What if I give you something like this? And I say here is 60 degrees. Like this, and I say 2 Newton. And I say 3 Newton. So will you still say that resolving to the horizontal, that here is cos and here is sine? No. In this case, if this is horizontal, this is vertical. If you are resolving this force to the horizontal, this is the angle. To the horizontal, you are opening up the angle. You are pushing it down, the angle is opening. So to the horizontal, this particular component is 2 sine 60 degrees. This particular force to the vertical, you are pushing it here, you are closing the angle. It is 2 cos 60 degrees. Here, this 2 Newton force to the horizontal, we are closing the angle. It is 2 cos 30 degrees. Now, to the vertical, you are opening up the angle. You are opening up here like this. It is 2 sine 30 degrees. So, we've been able to resolve this force to the vertical and to the horizontal, and this one as well. But let's focus on this. Now that you've been able to resolve this force to the vertical and horizontal, now we are resolving all the components. If I ask you, what is or are the vertical and horizontal components of this force, what would you tell me? This is what you will do. Vertical forces are all the forces acting like this. When you push them like this or like this, vertical downwards or vertical upwards. Horizontal is all the ones going this way. So, if we've been able to resolve this force to the vertical, it means here becomes, at this point, at this vertical, you have 2 sine 30 degrees. Now, if you're able to push this to the horizontal, it means at this point, here is 2 cos 30 degrees. And don't forget that we already have a force here, 3 Newton. So there's another force here, 3 Newton. And this force is acting at 0 degrees. So we can choose to say 3 cos 0 degrees. It remains 3. So long it is not inclined, the value remains. All these forces are the horizontal forces. And notice they are acting in one direction. If they were acting in opposite direction, you will have to subtract. For the vertical axis, this is the force. It is acting up. So the V component is 2 sine 30 degrees. The H component is 3 plus 2 cos 30 degrees. You add both of them, they're acting in one direction, which means the resultant vector arrow is equals, you solve this, you get a single answer, which is 2 sine 30 squared. The answer you've gotten squared plus 3 plus 2 cos 30 degrees squared. So any answer you get here is your resultant vector. Now the angle or the direction theta is equals tan inverse of the vertical component is 2 sine 30. Any answer you get for 2 sine 30, you put it here, over the horizontal component 3. Any answer you get for 3 plus 2 cos 30 degrees, you put it there. So basically, we've resolved a vector into magnitude and direction. Before we go straight into calculations, we are already calculating, like into questions and answers. Look at something else you should know. In life, forces act on different bodies. Human being, planes. To be able to survive, you must overcome forces. Look at it. If this is an aeroplane, for an aeroplane to fly, all the forces acting on plane are the drag force. As it's going forward, a force is pushing it forward, back. You are preparing for an exam, you see fun, enjoyment, laziness and everything, they are pushing you back. You want to read, things are pushing you back. Now, the weight of bodies always act downward, straight down. Weight is acting, pushing it down. What happens? For this plane to push forward, it means there must be another force which is referred to as thrust. Forward force, thrust. This thrust should be greater than the drag force. And a lift force that is lifting it up, should be greater than the weight. That is what keeps it moving. But the main thing I am drawing your attention to is weight. This weight acts down. As I am here, my weight is acting down. And when the weight acts down, opposite to the weight, there's another force trying to balance the weight. It is usually the normal reaction. You ask yourself, how about something like this? This aeroplane, or let's use car now, moving like this. What happens? This is the horizontal, weight is acting downward. Now, in this case, it is inclined. Here becomes our new floor or our new horizontal. Can we still say that the weight is acting straight like this to the horizontal? Because the normal reaction will always act straight to the horizontal. So can we still say the weight is acting here? No, we cannot. Since weight of bodies always act downwards, weight must act like this, at an angle. So if we are given this angle to be, let's use our 30 degrees, if that is 30 degrees, this means that this weight is now 2 components. Since it is already inclined, the weight has to be resolved to the vertical component and we have to resolve it to the horizontal component. So therefore, if you are solving for the vertical component, whatever you are getting, you must subtract weight from it, or the weight part of it is W cos 30 degrees. If you are resolving the weight to the vertical part of it, weight will be W sine 30 degrees, because here we are opening up the angle. So since it is inclined, it contributes to the vertical and it contributes to the horizontal. That is what happens when a force or a vector is inclined. You no longer say it always acts downward. No. Whether it is weight or not is not our business. Since this is an inclined plane and the weight is inclined at an angle, the weight is acting to the vertical and it is also acting to the horizontal. Ladies and gentlemen, let's see the questions I have in store for you. Like I told you, less of the talk, more of the business. Now, resolving vectors, you need a little touch of common sense. You need to understand both the diagram and the theory part. When you are given theories or questions written, you need to know how to think and convert it to diagrams. When you are given diagrams, you need to know how to convert them to text. Now, vector diagrams are very, very easy. After all, you are not drawing the skeletal system of your body. They are usually very easy. And anytime you are given vectors to resolve, no matter how big the questions are, no matter how complex, no matter how confusing, things you should know are you resolve vectors to their components or to their parts. You look for the vertical component, you look for the horizontal component. When you are able to get the vertical and horizontal component, you find the resultant, which is the square root of vertical component squared plus horizontal component squared. And theta, angle, is tan inverse of vertical over horizontal component. And 2, there are various rules for solving vectors. Triangle method, parallelogram, polygon method, whatever. Ladies and gentlemen, if you understand this general method, you'll be able to solve any vector. By the way, I will release a special video for vector to do the explanations, types, symbols, and everything you need to know under vector. But this class is based on request and it is purely calculations and resolution of vectors. Different questions from basic to advanced questions. Now let us embark on our procedures. This is where I will try to make it as simple as possible and as interesting as possible. The first question says, we should find the value of the resultant vector. What can we infer from here? This is simply a system, 2 forces, 6 Newton and 8 Newton, acting perpendicular to each other, acting at 90 degrees. And anytime we are given forces acting at 90 degrees, straight and straight, they are not inclined. The angle is 0 degrees. Food is ready. So we start with V. What is V? V, the vertical component. Vertical component is equals, 6 Newton. Then H, horizontal component or horizontal part, is equals 8 Newton. Ladies and gentlemen, there is nothing more to look at here. It is not inclined, so there is nothing we are resolving to the various axes. They've already resolved them for us. It is for us to take the different parts. What next? Arrow, the resultant. So the resultant is simply the vertical component squared, 6 squared, plus horizontal component squared, 8 squared. Now 6 squared is 6 times 6. What is 6 times 6? 36, right? Plus 8 squared. 8 times 8 is 64, if I can still remember. So this will give you the square root of 36 plus 64. That is square root of 100. 10 times 10 is 100. Therefore, the square root of 100 is equals 10. So the resultant force, or one force that gives us the effect of the 2 forces, is 10 Newton. So we're asked for the value of the resultant, and we've given them the value of the resultant. What if we are asked for the angle or for the direction? It will simply be theta will be tan inverse of vertical 6 over horizontal 8. But since we are not asked, I will not give you the answer. But if you feel you are asked, then punch your calculator and get the answer. For what we are asked, this is the answer. I'm looking at the next question. It says, find by means of vector diagram the resultant of two forces of 7 Newton and 3 Newton acting perpendicular to each other. Now, this is where the grammar and confusion comes in. Find by means of vector diagram. Ladies and gentlemen, don't let all these things disturb you. Let not your heart be troubled. Believe in yourself and understand the clues. Find the resultant of two forces of 7 Newton and 3 Newton acting perpendicular to each other. That is simply the question. So perpendicular means they are acting at 90 degrees. Now, if you can think very fast, you realize that this question is more like a written part of this one. This question can be written as, find by means of vector diagram the resultant of two forces 6 Newton and 8 Newton acting perpendicular. So this is a written form of this question. So we have 7 Newton and we have what? 3 Newton. 7 Newton and 3 Newton acting perpendicular. And we're asked to look for the resultant. As usual, you can turn this to right angle to have something like this. Then you apply your Pythagoras theorem, where here is the 7 Newton, here is the 3 Newton, then here is your hypotenuse, and the horizontal is the hypotenuse, line drawn to meet here and here. That is the hypotenuse. So that is basically the same thing, where 8 squared is 7 squared plus 3 squared. It's the same thing we are doing. But for us, the vertical component is 7 Newton and the horizontal component is 3 Newton. So resultant is equals 7 squared plus 3 squared. So 49 plus 9, 58. Therefore, the resultant is the square root of 58. Is that 7.62? Yes, Newton. This is the resultant of the vector. So this is more like 7.6 Newton. You see, the resultant is usually bigger, the hypotenuse. However, we are to look for the direction or for the angle. Let's say we are to look for this angle, theta. Theta is equals tan inverse of vertical 7 over horizontal 3. So this will give you 66.8 degrees. So the angle here is 66.8 degrees. Here is 90 degrees already. A right angle is 90 degrees. Now what will here be? Here will simply be, remember, the sum of angles in a triangle is 180 degrees. It means that this angle here plus 90 degrees plus 66.8 degrees, everything is 180 degrees. So if you are looking for this angle, it is simply 180 minus 90 degrees minus 66.8 degrees. But nobody asked us to do that. Nobody sent us. What they asked us is the resultant. So we finished what they asked us. This other thing we are doing is referred to as oversabi, which is not recommended for exams, but it's recommended for knowledge for practice because you may be asked. Let's look at the next question. A force of 4 Newton is inclined at an angle of 45 degrees to a second force of 7 Newton. Both forces acting at a point. Find the magnitude and direction of the resultant with respect to the 7 Newton. Wow! At last, something interesting. Something worth wasting time on. Yeah. But not in the exam hall. Don't waste time in the exam hall. But in practice, this makes sense. At your level, this should not impress you. What should impress you in vectors should be inclined forces where you need to resolve. It says a force of 4 Newton is inclined. Now, when something is inclined, it means it is forming an angle. It is not straight like this, and it is not lying down flat. So we know that it's inclined. Something that we already know that is that we have a force like this. It's inclined as 4 Newton. So the force is bent, not straight, not this, not perpendicular. And it says at an angle of 45 degrees to a second force. So if it is inclined like this, at angle of 45 degrees to a second force of 7 Newton, it simply means that here is 7 Newton. So when you are inclined to a particular angle, a particular force, it means that one is straight, horizontal, another one is being inclined on it. You need to be standing like this for somebody to be inclined on top of you. They both act at a point. So it simply means they start from this place. So this is going here, this is going to that place. Find the magnitude and direction of the resultant with respect to the 7 Newton force. In other words, find the magnitude and direction the force makes with the horizontal. Because when you mention 7 Newton, it is the horizontal force. So, ladies and gentlemen, nothing to look at here. Nothing to look at here. So, this is like this. In a normal sense, this is our vertical. But we don't have a straight vertical force. So, we therefore need to push the force given to the vertical. And like I told you, anytime a force is inclined, that force cannot be said to be vertical or horizontal. It has both. You resolve to the vertical, you resolve to the horizontal. So, or you resolve to the horizontal first, you resolve to vertical. Anything that happens, it is fine. So here, we resolve here, we resolve here. Let's look for the vertical V. For the vertical force, we don't already have anything here. Then the next thing we have is this one inclined. So if you push this one here, we are opening up the angle. You are pushing here, the angle is opening. And opening up is what? Sine. So vertical is 4 sine theta. And theta is 45. 4 sine 45 degrees. Then you look at any other thing to the vertical? No. Then let's go to horizontal. The horizontal force, we already have 7 Newton. 7 Newton or 7. Now, it is not inclined. It is at angle 0 degrees. If you choose to do over sabi, you feel if I put only 7 here, it will not make sense. You need effect. You can say, okay, since resolving to the horizontal, we are cosine, so 7 cos 0 degrees plus this 4, we push it down, we close the angle, that is cos 4 cos 45 degrees. And cos 0 is 1, so 7 times 1 is 1. So we have 7 plus 4 cos 45 degrees. So let's observe again. If this gives you 2.8, I am right. If it doesn't give you 2.8, I am wrong. But whether I am right or wrong, it's not the problem. The thing is, understand what we are doing, you do the correct one. So here I should give you 9.8 Newton. That is if I am correct. So we found V, we found H. The next is the resultant. R is equals the square root of V squared 2.8 squared plus 9.8 squared. This will give you 10.2 Newton. If I am correct, if I am wrong, then you are right. And the direction, theta, is equals tan inverse of vertical 2.8 over horizontal 9.8. So this should give you, that should be around 15.9 degrees, approximately 16 degrees. So that is it. The resultant 10.2 Newton and the direction 16 degrees. Ladies and gentlemen, here we go again with 3 questions on the board. Here we have 3 velocities acting, V1, V2, and V3. Here we have 3 forces acting, and here we have 4 forces acting. So this is our positive S axis, this is our negative S axis. And when you go down, you have negative Y, this is positive Y. First question so far, we are seeing forces or velocities or vectors acting in both the negative and positive part. Look at something else. This, you see, V2 is going up, V1 is going up this way, and V3 is going down. Which means V3 is going opposite to V1 and V2. And when you are solving questions in vectors, you add vectors going in the same direction. Virtually, the questions we've been solving so far, the arrows are going in the same direction. So we are adding. But first time here, we'll have to subtract. Enough of the words. Remember, less talk, more action. Let's see how it converts. As usual, we look for the vertical component. V is equals, this force, this velocity is going up 15 meters per second, V2. So that is 15 meters per second. Or since it's at 90 degrees, you can say it is at 90 degrees to this. So you can say 15 sine 90 degrees, since it is at 90 degrees to the vertical. Or you leave it that way. Plus, this is inclined at 20 degrees. And I told you that once a vector is inclined, it has both horizontal and vertical component. Now that we are looking for the vertical component, what is the vertical component of V1? It is simply 10 sine 20 degrees. You are pushing it up. Now when you push this arrow up this way, it comes here. You see that the arrow goes up just like this. They are in the same direction. We add. Then, what other vertical component do we have? We have here 7 meters per second, and it can be resolved with, we can either resolve it to here or to here, but let's resolve it to here. Resolving to here, it is, we are opening up this 10 degrees. So opening up, it becomes 7 sine 10 degrees. But it is in opposite direction to this, or it's acting in another direction. Instead of plus, it becomes minus. So minus 7 sine 10 degrees. That is the vertical component of the force. This will give you 17.5 if I am correct, according to my calculation. 15 sine 90 plus 10, 17.2 meters per second. Then the horizontal component of this vector is simply, there is nothing here, but this and this are inclined, so they have both vertical and horizontal. So resolving this, we have 10 cos 20 degrees. You are closing the angle. Minus 7 cos 10 degrees. Why? When you resolve here this way, it comes here to form something like this. This one comes here to form something like this. So they are opposite direction. You subtract. So this will give you 2.5 meters per second. When you have the vertical and the horizontal components, life has been easy. What do? You look for the resultant. So the resultant is equals 17.2 squared plus 2.5 squared. That is your resultant. So from my calculation, it's 17.39 Newton. And theta is equals tan inverse of 17.2 over 2.5, I guess. Will that give you 81.72 degrees? 81.72 degrees. So if I am wrong, you are correct. So let's see your answer. This is the same thing like this. This is the vertical y-axis. This is the horizontal. All the forces here are acting towards the positive direction, and they are all acting in the same direction, which means minus may not come to play. What else? Looking at this, you see this is inclined to this at 30 degrees, but this one is now inclined to this one at 30 degrees. But when you are resolving vector, we are resolving everything to the horizontal. So when you resolve here to horizontal, we have 30 degrees. When we resolve 16 degrees to the horizontal, we have 30 degrees plus 30 degrees. That is 60 degrees. So the angle 16 Newton makes with the horizontal is 60 degrees. If there were another one here, let's say 10 degrees, its whole angle will be 30 plus 30 plus 10, 70 degrees. So that is how you do questions like this. So the vertical component will simply be, there is nothing here already. So 16 sine 60 degrees plus resolving 4 Newton here, 4 sine 30 degrees. So this angle of this 16 Newton is 60 degrees. The angle of the 4 Newton is 30 degrees. So that should give you 13.46 Newton, if I'm not mistaken, according to my calculation. Then horizontal is equals, we already have here, so at angle 0 degrees, so that is 2 cos 0 plus 4 cos 30 plus 4 cos 30 degrees plus 16 cos 60 degrees. 16 cos 60 degrees. This will give you 15.86. So with this, food is ready. The resultant will simply be equals 13.46 squared plus 15.86 squared. And the angle or the direction is equals 13.46 over 15.86. In this case, we are asked to look for just the magnitude, and that should give you 20.8 Newton. So ladies and gentlemen, the magnitude of this vector is 20.8 Newton. The direction is this, which you can find by yourself. We are actually not asked. We are asked to look for the resultant of the forces. So we have 4 forces acting. As usual, we look for the vertical component, the horizontal component, then we look for the resultant. In this case, the vertical components are, we already have 3 root 3 standing vertical plus 10 sine 30 degrees. This is being resolved this way. It opens up. Now, this one is inclined, which means it will have vertical and horizontal components. But this time around, it is towards the negative y direction. And it is acting in opposite direction, as you can see. So forces acting in different directions are subtracted. So these two are the same direction, we've added. So since this is acting in another direction, When we resolve to this part, it becomes something like this. So it is opposite. So minus 6 sine 60 degrees. This will give you 5 Newton. For the horizontal, we already have 3 here. 3 plus 10 cos 30 degrees. This is acting here. Resolving here, it will still act in this direction. Minus 6 cos 60 degrees. So this is, we resolve this here, it comes to the horizontal direction, but opposite to the other ones. So we subtract it. Everything here should give you 5 root 3. So the resultant is 5 root 3 squared plus 5 squared. So I got approximately 10 Newton. If you got something else or you have issues with the calculation, let me know. Now, the problem most persons have when it comes to resolution of vectors is not punching calculator. It is not finding magnitude. It is not even finding direction. It is simply knowing the vertical and horizontal components, knowing how to resolve into horizontal and vertical components. This is why the major parts of this question, what I will simply do is resolve them for you, then you punch the calculator, find the magnitude and direction. On a serious note, that should be a simple task, right? Yes, it is. So in this case, the vertical component is 10 sine, let's put here 20 degrees, 10 sine 30 degrees plus 12 cos 20 degrees. Now in this case, we are closing 12. So when you close it towards this part, it is cos. So 12 cos 20 degrees. Now this one is also inclined, which means it has both the vertical and horizontal components. And don't forget, we already have 9 here, which is acting in opposite direction. So this should be minus 9 minus 15 sine 60 degrees. 15 sine 60 degrees. So the vertical component is 10 sine 30 degrees plus 12 cos 20 degrees minus 9 minus 15 sine 60 degrees. So this is something as 10 sine 30 degrees plus 12 cos 20 degrees minus 9 plus 15 sine 60 degrees, which means add the two going in the same direction, add the two going in the same direction, subtract them. So from here, you get your vertical component. How about the horizontal component? It is simply, okay, nothing straight here, nothing straight here. So we have 10 cos 30 degrees, 10 cos 30 degrees, plus, when we resolve here to this place, it goes in the same direction. 60, 15 cos 60 degrees. This one can also go horizontal because it is inclined. So it will simply be minus 12 sine 20 degrees. So that is basically it for this vector. You get the value here, you get the value here, you look for the magnitude and direction. And let's see question number 9. In question number 9, you see all the vectors. No one is actually inclined. No one is inclined. So what do? You simply say that the vertical components they are both going down. This is going down, this is going down. So this is minus 50 minus plus minus 35. They are going in the same direction. You add them, but since they are going down, you can put a sense of minus. So this is minus 85.5 Newton. They are going downwards, negative axis. So you subtract. Then looking at the horizontal component, this is going here. This is 20 Newton. So 25 minus, this is going here, minus 20. This will give you 5 Newton. So the vertical component of this force is minus 85.5 Newton, if I am correct. Then the horizontal is 5 Newton. Here I made angle 30 degrees. 40 Newton makes an angle of 60 degrees. 50 Newton makes an angle of 30, 60 plus 30, 90 makes an angle of 90 degrees. So the horizontal. 30 sine 30 plus 40 sine 60 plus 50 sine 90 plus 60 sine 120 degrees. So that is it for the vertical. While for the horizontal, we simply have 20. It's already here. 20 plus 30 cos 30. 30 cos 30 plus 40 cos 60. 40 is 30, 30, 60. So 40 cos 60 degrees plus 50 cos 90 degrees. 50 cos 90 degrees plus 60 cos 120 degrees. Now take a look at something. Cos 90 is 0, which means 50 cos 90 here will give you 0. That further shows that this one is only vertical. It is not horizontal. So no need for here. Actually, like we've been doing, this simply becomes 20 plus 30 cos 30 degrees plus 40 cos 60 degrees plus 60 cos 120 degrees. So this is your horizontal component. So resolve that, find the resultant and find the direction. And the last question says, a machine 1.5 meter long and weight 100 Newton is supported by 2 ropes, W and CD as shown. Calculate the tension in the rope. When you tie a rope to this thing and you are pulling it, tension on the rope is the pull force, that pull that is going up, and the weight is acting opposite the tension. So the pull is equals the weight. The tension is equals the weight. You are given something like this. Now look at here. The T1 is going at angle 60 degrees to B at B. Here at angle 45 degrees, tension 2. This is almost something like this. Not almost. Something like this. Here, T1 at 60 degrees. Here, T2, tension 2 at 45 degrees. What else? They gave us the weight. Weight is always acting down. So weight is 1000 Newton. Resolving this to the horizontal, T1 cos 60 degrees is equals T2 cos 45 degrees. Why? Because the horizontal is T1 cos 60 degrees minus T2 cos 45 degrees. They are acting in different directions. But in this case, we are dealing with tension. And when it comes to tension, it is opposite the weight. we have the weight, we have the tension. So for this area, T1 cos 60 degrees is equals T2 cos 45 degrees, trying to balance. Now, you may be wondering, why did we not use normal V is equals this? No, because in this force, you see this is pulling this way, this force is pulling this way. You have two forces going. So to balance the forces, this force should be equated to this force. That takes us to T1 is equals cos 45 degrees over T1 is cos 45 degrees over cos 60 degrees times T2. And remember, earlier this class, I said I'll be solving questions from simple to advanced questions. So if this part of it is becoming somehow difficult to you, know that it is for advanced learners. Weight is equals tension. So for the vertical resolution, T1 sine 60 degrees plus T2 sine 45 degrees is equals 1000. So the tension is equals the weight. And we already have T1 to be 1.414 T2. So here becomes 1.414 T2 sine 60 degrees plus T2 sine 45 degrees is equals 1000. So 1.414 sine 60 degrees times 1.414 T2 plus sine 45 degrees times T2 equals 1000. So from here, you look for T2. When you get T2, then substitute T2 here to get T1. Ladies and gentlemen, resolution of vectors from simple to advanced. That is it. So if you are not angry with me at this last part, we are still friends. So thank you. Let me know if you found this class helpful, and let me know if you had issues. Thanks for watching. Subscribe to this channel for more amazing videos, and don't forget to tell your friends about Flash Learners. Enjoy.